My name is John Horgan. I'm a longtime correspondent for whatever this show is called now. It's, I think, MindBody Problems, but it's part of Meaning of Life TV and Blogging Heads TV, this platform created by Robert Wright. I also teach at Stevens Institute of Technology. I'm a longtime writer for Scientific American. And with me today is another science ink-stained wretch, Michael Brooks. And I'm really thrilled to have you here, Michael, because we share some common obsessions, and we also have a history. So I'll ask you about that in a second, but can you just give us an introduction of who you are and where are you right now?
So right now I'm in a town called Lewes on the south coast, or almost on the south coast of England. So I'm like 50 miles south of London is where I live. And it's getting dark, so I'm going to have light issues probably in the next few. Well, we'll see. We'll see how that goes. So I work as a science writer. I am a consultant to New Scientist magazine, and I write for various other people. You know, I write for Nautilus these days. I'm writing for Guardian, but I'm also writing a lot of books now, which. Yeah, my attention span has got longer and longer. So, where I used to write science news stories, now all of a sudden I'm writing like 90,000 word books. So, that's progress in my life.
Right. Well, you have a book that came out recently that I've read, and I want to talk about it because I love it. I'm just going to hold it up now.
Oh yeah.
Called the Quantum Astrologer's Handbook. It's really great. I don't know if this is the
US edition.
Okay, US edition.
Yeah, that is the US edition.
But before we get to that, first of all, I want to mention that you're not just a science writer like I am. I mean, I majored in English in college, and then I went to journalism school. So I have actually no right to comment on science, as scientists often point out to me. You've got a fucking PhD in physics.
So I have a PhD in quantum physics. I did my PhD like many eons ago. But I pretty much left as soon as I finished my PhD. I kind of decided that my heart was more in kind of, surfing around and seeing what other people were doing than it was in kind of putting my head down and just doing this one thing in the lab for the rest of my life. And it didn't help that my supervisor was a bit of a psycho as well. So it was good to get out of there. And,
your supervisor was John Barrow, right?
No. And let that not be said. I'm not even going to name my supervisor.
Oh, okay. After calling him a psycho, I guess that's wise.
Yeah. But no, it wasn't John Barrow. I can tell you that. John Barrow was a great guy. And so I got out and started writing science stuff pretty much straight away. And just sort of decided that it was useful to have a PhD, right? I mean, I think you have every right to comment on science, by the way. Don't let any scientist tell you anything else. I think everybody has a right to comment on science. But the thing was that I think having the PhD did open some doors. It made life a little bit easier in terms of, you're the kind of one of us. But that made it all the worse when I kind of turned on them as well. So, so it's like, you're one of us. How can you be so critical of what we're doing, or don't you understand? And so, I mean, there's a general problem, I guess, we could talk about in science journalism, that it's just not critical enough. It's sort of, it's cheerleading so much of the time. It's like, yay, scientists have done this great thing, and isn't it amazing? And the world's going to be a better place. And as we know, that's not really how things work out.
Yeah, absolutely. Well, I certainly agree with you there. But so I want to come back to science writing, because your science writing, you're doing some really interesting experimental things with your writing, certainly in Quantum Astrologer's Handbook. But first, I've got to bring up our shared history. So I met you in 2005. We both got this fellowship from the Templeton Foundation, which they probably won't like it when I describe them this way, but really what they do is try to foster dialogue and even reconciliation between science and religion, or maybe science and spirituality, if you want to be a little more vague. And so there were what, like maybe 15 journalists who were all
I think
brought
so, yeah.
to Cambridge. And it was like first class treatment. This is for 3 weeks. And we had a series of scientists and philosophers come in to talk about science and religion. And the I'd say token atheist was a really good token atheist. It was Richard Dawkins.
It was, yeah, yeah.
And there was one particular night where we'd been hanging out with Dawkins all day and talking, and I think we'd had dinner, and then we're drinking, and there was a group of, I don't know, maybe a half dozen of us who were talking to Dawkins, and you know what I'm talking about, right?
Yeah, I do. Yeah, it was. Do you want me to? I mean, I can tell the story. So, so the backstory of this is that so ever since I was like 13 years old, have been involved in evangelical churches, particularly one in my hometown where I grew up, and I was like a fully paid up member. I was really involved, and all through my adult life up until this point, I was heavily involved, committed Christian in the evangelical churches, which you and others will be aware of, the kind of hardcore Bible is truth kind of stance. And I was very much part of this. And people, in my career had found it quite difficult to reconcile this because, I was doing science and how did that fit with my sort of beliefs about Christianity? And the truth of it was that they were completely compartmentalized. So I had never really sort of tested one against the other, never felt like they had to compete. And part of my reason for taking that fellowship on was because I just kind of felt like it was time to, actually ask a question, I guess, and see whether, my faith stood up to this kind of interrogation. And I remember we met on the first day we were there, and you said to me, "No way, man, you're going to be an atheist like next time I see you," and which was really interesting. So anyway, so this is the kind of setting the scene. And one of my experiences as a Christian, I spent a couple of years in Africa, in West Africa, teaching physics in a high school. And one of my experiences there was I went to a revival crusade meeting. It was run by some American guy whose name I don't remember. And it was a big thing in the stadium. And we had this, the kind of, fiery brimstone kind of talk. The preacher was preaching. And then he asked people in the audience to be praying for each other. And, I was there. I was a committed Christian. I was willing to sort of pray for people. And he was like specifically like, God's going to heal the sick amongst us tonight. And I want you to, if you're sick, if you need prayer, I want you to find somebody to pray with you. And so I kind of turned around. There was this woman, as I recall this story, there's this woman who was stood there who had what I now know, I didn't know at the time, cataract. So this is, by the way, I mean, I'm sort of 25 years old at this point, right? So this is the mid-90s. And she had cataract. And she asked me to pray for her, and I prayed for her. And when I looked at her again, the cataracts were gone, right? This is, I'm telling the story as my memory of the story. And this completely freaked me out. Like, I mean, I'd been a Christian for, all my adult life, through my teenage years, and I never encountered anything that was like remotely miraculous. So this, not only had I kind of thought that I'd seen a miracle, I also thought that, I had been the kind of the vessel that conveyed this miracle. And so this, this freaked me out. And I actually just walked straight out of the stadium at that point. I was like, I just could not deal with it at all. And especially as everyone else around me was asking me to pray for them as well. So it was like, kind of double jeopardy. It's like, I'm not doing this again. This is like too much for me. So I got out. So anyway, sort of, what would it be? It would be like 10 years later. We're gathered in this room in Cambridge with Richard Dawkins. And I tell Richard Dawkins this story. Yeah. Because I wanted him to kind of, I wanted to get his opinion on it. He was very fiercely atheistic. And this is, interestingly, before the God delusion comes out. So this is before everyone knows that he's like this rampant atheist guy. And he had just read us, literally, I think the first draft of the first chapter of the book or something, when we'd had this seminar, so he'd sort of tried it out on us and wanted to know our reaction. So we've been discussing this stuff. And I said, Richard, here's a story. Here's something that happened to me. So I can tell you it definitely happened this way. What do you make of this? And he said, he listened very intently and very respectfully and very gracefully actually said, well, I don't know if you've heard about this, but actually a lot of these kind of, big time preachers and missions, crusades, especially when they're in the developing world, they tend to use plants in the crowd. So they will put people in the crowd who pretend to be ill in some way, or something about them, that needs healing, and then they pretend to be healed. And then the idea, if you're going to be charitable, the idea is to increase faith in the crowd. If you're not going to be quite so charitable, it's basically duplicitous and deceitful and a means to get money out of people. And he said, it may be that this happened to you, that you were just the victim of somebody who was, scamming you and scamming the people around you, and maybe even was paid by the mission people to sort of somehow, make this miracle seem like it happened. She was blind and now she can see. And this had never, ever occurred to me, right? This had never occurred. I'd never come across this in my experience of being in churches and talking to people in churches. Nobody had ever mentioned that there was this kind of thing went on. And I just kind of went, oh, okay, well, that seems like a good explanation. It's certainly a less sort of implausible explanation than I did a miracle, right? I mean, that's how I feel about it. And so my feeling was that I had to take that on board. And what for me had been one of those moments that was a kind of defining moment, like God must be a real thing, suddenly had an element of doubt to it, I guess, thanks to Richard Dawkins. And I think my faith basically went on to crumble from there.
It's funny. See, what I remember, so I was right there and I was enthralled by the whole interaction. Your story was amazing. What I recall is that there was another exchange at the end where I think maybe I said to Dawkins, is there anything that would convince you that a miracle really had taken place? Can you imagine being presented evidence of a miracle? And Dawkins, and I thought he would just say, no way, there's always got to be a natural explanation for these things. But he, again, as I recall, he sort of thought about it. He goes, well, if the evidence was there, I would have to take it seriously, that maybe this had been some kind of medical miracle. And I remember being astonished that he said that, because I would completely dismiss any report of a miracle. I would think that there has to be some explanation, a natural explanation. And so I felt like at that moment, Richard Dawkins was much more open-minded than I was. And it made me really it made me admire him. He was really sort of, he was really very respectful toward you, as you said, but also showing this extraordinary open-mindedness. And that's always stuck in my head.
Yeah, I have to agree with you. I think the problem came when he sort of got elevated to this status of the chief atheist, and he started to sort of take the nuance out of some of his arguments, and so he became this incredibly difficult, confrontational, cantankerous Oxford academic. And actually, when you talk to him one-on-one about these things, and I have done since, we've met a couple of times at conferences and we've talked, by email and on the phone. And when you talk to him about these things, he is full of nuance, and he understands like why religion exists in the world. He understands, that actually human beings are naturally religious, and these things are kind of hardwired, and it's cognitive effort to be an atheist. It's not the other way around. It's not like it takes a lot of cognitive effort to believe in God. And he understands all these things, but he leaves those out of his, very public discourse arguments, and just kind of calls people stupid or, simple-minded or whatever, which is, I know that's not what he actually thinks. It just suits his kind of rhetoric at the time. And so, I think the public and private face of Dawkins is they're different things. And I think that's actually a real shame, because he actually is a gracious, as you say, respectful guy, and was actually, I felt, quite helpful to me, and wasn't, condemning me in any way, but, also just opened my mind to other possibilities and other ways of interpreting that event that had meant so much to me, and did it very gently.
Yeah. Well, that was one of the high points of my science writing career.
It was fun. I mean, the whole thing was great fun.
It was. But it seems to me that since then, you might not be a Christian anymore. You might not believe in any kind of conventional God, but in your science writing, you were very much exploring some of these border areas between faith and science, and questioning some scientific dogma, and also taking seriously some ideas that would be dismissed as pseudoscience by most, certainly by like kind of the hardcore skeptic atheist types,
yeah,
like Richard Dawkins. Is that fair to say?
Yeah, I think so. I mean, I'm in my head, I'm as skeptical as everybody else, but I'm sort of aware, maybe more than some others, that scientists are human beings, and that they're not robots. They like to portray themselves as dispassionate robots, that have no agenda at all apart from to uncover the truth. And of course we know that's not the case at all, and that everybody has their kind of human foibles, and we have this sort of strange situation where science is this effort to overcome our biases and overcome our natural inclinations to superstition. Arthur Eddington was so obsessed by the fine structure constant, this electromagnetic constant, which basically boils down to 1/137, that he became obsessed by the number 137. And I read something recently that said if he was in a conference hall or something, and he was leaving his coat, if there was a peg 137, he wanted his coat on that peg, kind of thing, just the kind of irrational, strange things. And so what I've always tried to do is kind of explore some of those areas where there's a clash between the values of science as they're laid out in, I wrote this book called Free Radicals, The Secret Anarchy of Science, where I was kind of talking about science as a brand. And I think the brand, science, has these very clear brand values of, we're a safe pair of hands, we're entirely rational, we're not emotional in any way, we're just, and of course, that's just not how science works. And you look at the history of science, and it's full of people who are losing their shit over contests with their colleagues, and there's people taking LSD in order to train their brain to discover how to replicate DNA, and people do all kinds of stuff that doesn't really fit with the brand. And I've always been really interested by those things. I've been interested by the things that scientists can't explain after decades of attempting to explain those things. So things like things that are very mainstream science, like dark matter, for instance, this missing matter of the universe, which we've known has been missing since 1933, and we've never found it, and we're still looking at it. And I just read a story yesterday where it's like, it's time to ramp up the search for dark matter. It's like, that time has long passed now. It's interesting, but you can't say it's time to ramp up the search. We're going to be hitting the centenary of the discovery of dark matter, in our life, in the next sort of, 22 years, 12 years, and yet it's like, we can't say it's not there. We have to have it. We just have to keep looking for this stuff. And so you get this kind of interaction of, I guess, what is human psychology and science, and this kind of, and then there's the kind of mystic side of this obsession we have with saying, wanting to make sense of the universe, and thinking we have to, somehow sort of make sense of the universe. And so you get things like, Carl Sagan, who says, we're a way for the universe to understand itself. The famous quote from Carl Sagan, which is a lovely thing. But actually, it's effectively, that's Carl Sagan setting out his stall for a new cult, if you like. It's like, that's how we should see ourselves, as a way for the universe to understand ourselves. It's a few short steps and leaps there, and you're kind of in the realms of L. Ron Hubbard, aren't you? So
I can. This is why you get in trouble with some of your scientific former colleagues.
Well, yeah. I mean, but I think it's really interesting. I've often thought, my PhD is in quantum physics. There's so much that's so interesting about quantum physics. And the older I get, I guess the more interesting it becomes to me, because you realize how little we understand. And also, not only that, but how many decades of people sort of fighting with each other over how to interpret it and what this means and what that means. And I've been at conferences where people have almost like had a stand-up row over breakfast, because I believe in many worlds, and if you don't believe in many worlds, then you're stupid, and that kind of thing. And it's just fascinating kind of sociology, really.
Absolutely. Okay, so that's a good segue to your book, Quantum Astrologer's Handbook.
Yeah. Okay.
So can you just, because it's a book about sort of early, I don't know, what is this? Early Renaissance?
Yeah, very early Renaissance. So it's sort of it opens at the beginning of the 16th century, and the book is focused on this guy called Jerome Cardano, who's an astrologer. Once he gets through college, he trains as a doctor, and this is in Milan, in Italy. So he's born in 1501. He trains as a doctor eventually. He's not allowed to practice, partly because while he was a medical student, he wrote a book and published a book about how little doctors understand about what they're really doing. So he's denied, and this guy had no idea how to interact with people at all. He's kind of hilarious. But I became obsessed with him, the more I read about him, because he was so open to all these kind of, thinking differently. He didn't care what people thought of him. Well, he did care, but he couldn't help himself from alienating those around him, if he didn't agree with them. So he pissed off all the doctors in Milan and was refused a medical license. So he ended up treating people undercover after dark and stuff. And he got himself through medical school by gambling in the taverns and pubs and inns and stuff. And he realized that in order to win and make enough money to live, he had to work out how gambling kind of worked. So he wrote down a load of notes on probability, looking at a deck of cards or a roll of a dice, what are the outcomes? How should I bet? And this kind of thing. And this was the first incursion anybody ever made into probability. He never published it in his lifetime. It was found after his death, these notes, and it's published as on Games of Chance, which is the first book on probability. And so he's sort of this, but he's still hopeless at gambling, still loses loads of money, even though he's literally the only guy on the planet who understands what's going on. And and so he becomes this underground doctor, and eventually he gets recognized as being actually a pretty skillful doctor. And he manages to get elevated, and he gets elevated right to the point where he is one of the most famous men in Europe. Halfway through the 16th century, he gets called to Scotland from Italy to treat the Archbishop of Edinburgh, who has terrible asthma and is sort of doesn't know where else to go. Sends a letter to Cardano. Cardano travels up through France. He's not allowed into Lyon before they've laid on a civic procession for him. That's how well known he was. He's not allowed to leave Paris until they've held 3 conferences in his honor. And he goes down the line, and when he's in Scotland, he gets a call from the King of England to come and treat him as well. So this is the kind of level at which he's operating now. And then towards the end of his life, he suffers enormous academic problems with his colleagues who are jealous of his status and everything else. Gets kind of absolutely scuppered, and then he gets arrested by the Inquisition, and he's sort of put under house arrest, not allowed to publish or teach or do anything for the rest of his life, and so disappears. And this is why none of us have ever heard of him. He just a few mathematicians know about him. There's now some sort of scholarly literature about him, but it was amazing to me to find this guy who was asking questions about astrology. He was a practicing astrologer who, because it paid the bills, basically. It was another way of paying the bills. But while he did that, he also published works on how the public could look up at the sky and kind of interpret the stars for themselves. And this star is here and this is there, and you'll see this move through the sky. So he published a guide to astronomy, as a way of proving that he wasn't just a charlatan. He published this book on medicine saying, don't believe everything doctors tell you. And so he was this incredible sort of skeptic. He was skeptical about astrology. He said, I don't know why this should work. And I'm not even sure it does work, but that's a kind of heretical sort of way of seeing things. So I just kind of became obsessed by him and this ability he had to kind of question everything he was an amazing mathematician as well, and like, you know, was responsible for us solving like the quartic equation, x to the 4 kind of equations. And he couldn't get on with anybody.
And he was one of the first people to play with imaginary numbers, right?
Yeah, so he absolutely. So people in the past had seen that if you had, so an imaginary number, a square root of -1, right, it shouldn't exist. Mm-hmm. And he had seen, people, mathematicians in the past had seen sums that had to be solved that included these square roots of negative numbers. And they just thought they'd done something wrong in their calculations before, or they literally just ignored it and pretended those were positive numbers. And he was the first one to say, no, this is real. And actually, I don't know what to make of it. I don't know what these things really are, but they're definitely part of, you know, how we have to take mathematics forward if we're solving algebra. So this is all about understanding algebraic equations. And so he faced up to it, you know, and then a couple of decades down the line, one of his, so another Italian guy called Raffaele Bombelli actually took it further and did what we know now as complex numbers and said, oh, we just separate them out into real and imaginary numbers. So Cardano was like, you know, this stuff is real. I don't know how to deal with it, but it's definitely something that somebody should deal with. And what made it, why I call him the quantum astrologer, is because he invented probability theory and imaginary numbers. And those two are the central pillars for quantum theory. You can't do quantum theory without them. So I can, in the book, I go back and talk to him about all that.
Right. Well, so what I like about him is that he seems like a very modern figure, and the way that all these different contradictory things are swirling around in his head. And he's trying to get by in life. He's trying to make a living. He's trying to find love, and he's got a really complicated family life. He's also trying to figure out how the world works. He's obsessed with understanding nature. And I appreciate that, because I've been obsessed recently with the mind-body problem, and which seems to me to be kind of at the bottom of every single scientific mystery. You know, you keep going and you end up with the relationship between mind and matter. Yeah. And I wrote a book a couple of years ago called MindBody Problems, and the thesis was that all our efforts to understand the mind-body problem, which are sort of efforts to understand ourselves and our relation to the world and to other people, it's always subjective. We can never make this an entirely rational scientific enterprise. And Jerome seemed to embody that. And I feel like we're still, you know, the idea of the age of reason and the scientific revolution, it suggests that at some point we went from that kind of medieval, superstitious, nonsensical way of understanding the world to our modern, enlightened understanding of the world. And that's just obviously bullshit. And what I like about the book also is that you implicate yourself as the narrator. You're also trying to sort of navigate the world, and you know, you're steeped in quantum mechanics, and you're sort of, after decades of looking at quantum mechanics, you're sort of going, what the fuck? I don't know what it means. Nobody else does either.
So for me, what was interesting was that I kind of, you know, I became obsessed with Cardano, and I was really like even more obsessed with him once I realized that he had this strong link to quantum theory. And then I realized that actually I'd never, ever written in any of my books about quantum theory. You know, sort of, you know, at this point, I had like, you know, 6 or 7 or 8 books behind me, and I'd never touched this subject, which was supposed to be my subject. And so I sort of thought about it a lot. And I realized the reason is that nobody actually understands it. I didn't want to write another one of those books as like, oh, here's why quantum theory is really cool. And, you know, and it just felt like to me, it wasn't cool. There's nothing cool about this thing. You know, this is an unsolved mystery that everybody sort of portrays as if it's like the greatest thing that we've got. And yeah, it works, and you can calculate stuff. And, you know, obviously modern technology relies on it, on our understanding of it. But at the same time, you know, you can buy a quantum cryptography device and nobody in the universe can tell you how that thing works. because it works through quantum entanglement, and quantum entanglement is this utter mystery, So we can make technology out of it. It doesn't mean we understand it. So I wanted to write a book that was kind of honest about, where we are with it, and what the problems are, and where those problems come from, and which kind of bits have been ignored, and why people haven't really solved any of this, or made much progress since the 1930s.
So this is another reason why I reacted so strongly to your book. Is for the last 6 months or so, I've been trying to, as a kind of COVID project, I've been trying to learn quantum mechanics with the math for the first time in my life. So for decades, I've been pontificating about quantum mechanics without knowing anything about it, really. I mean, I sort of know it from the outside. I read the popular books, I talk to the experts, but I never understood what the Schrodinger equation is. I didn't know anything about, people would refer to matrices and things like that, Dirac notation. I don't know what they're talking about. And I just decided to try to do something about it. And the weird thing is that the more, and I actually just finished taking a course at my school. Well, next week will be the last week, an introduction to quantum mechanics, for engineering applications.
Okay.
Because I teach at an engineering school. So it's kind of shut up and calculate that philosophy. Virtually no attention to interpretations or anything like that. But the more I'm sort of learning about quantum mechanics, and of course my understanding is still ridiculously primitive. Differential equations just kill me. I have a really hard time with that. But I'm becoming more and more suspicious of the whole enterprise of quantum mechanics the more I get into it. And I'm also becoming more suspicious of the whole idea, this kind of faith of physicists, that ultimate reality is mathematical, and that our final theory will be this beautiful mathematical theory, that's the way to understand the world. The mathematics, at least in this point in my effort to learn this stuff, seems so arbitrary and kind of kludgy.
That's interesting. Yeah.
I mean, I just discovered recently that the Schrodinger equation, I mean, this is every physicist knows this, that it can't provide a precise description of a helium atom. And, because a helium atom is an example of a 3-body problem. So you need all these sort of patches and approximations and everything. And yet the physicists, Stephen Hawking talked about the quantum, the wave function of the entire universe. So where do they get off with this hubris? So anyway, this is my next book project, to write about quantum mechanics and mathematics and what they actually tell us about the world. But I'm curious, what do you think is going to happen with quantum mechanics? I don't know. My speculation is that since we've basically made no progress whatsoever in 100 years, apart from people putting together, like Everett putting together his many worlds idea, and it's mathematically based, and but the thing is, the mathematics takes you so far, and the thing about quantum theory is you can work with the mathematics, and like you say, you can do the calculations. You can shut up and calculate and just say, I'm going to get this out of this experiment. I'm going to get that out of that experiment. But it doesn't tell you actually what's going on in any of the experiments. You need these interpretations, as they're called, in order to say something about the nature of the world. And it seems to me they just fall really short. I mean, I'm sure that none of the interpretations we've got at the moment are right. I think they're not even very good answers to things. So you have something like many worlds, and then people take it to the extreme where they say, oh, that means there's another version of you in another universe. And I'm like, shut up. I mean, really? Because, in order for you to make that statement, you would have to understand what it means to be me, i.e. you would have to understand what consciousness is, because you are talking about a version of me, and as far as I'm aware, there's only one version of me, because I'm conscious of myself, and I don't know if anybody else is conscious. I don't know what consciousness actually is. So for them to, sort of then suddenly make this leap to, like, there's another version of you in the other universe, and when you die here, this version of you will live on,
which is what Everett believed. I mean, Everett said, I will never die. There will always be some version of me that's alive. And that's just, I mean, it's sort of philosophy, but it's bad philosophy, right? I mean, it's not great. And it just shows, the massive gaps in between what we know in the maths and what the maths says about the world, and then the thing we try and lay on top of this, like it's some super heavy like piece of concrete that goes on top of this, and then we walk across it and say, oh, we've got this other universe with me. But what you've just squashed under that piece of concrete is the only bit that actually matters, which is what is the maths of quantum theory, which was only set up. I mean, I give this talk called Quantum Theory for Beginners. And I kind of do it in bars and pubs and in England. It's kind of good fun because people come along and they've heard of quantum theory, but they don't really know what it's about. So I start off with all those quotes, like, if you think you've understood quantum theory, you haven't understood it, and if you're not shocked by it, then you haven't understood it. And I was like, this is the reason you're here. Like, everyone tells you this amazing sort of theory, and actually the truth is we just don't understand. That's why we sort of dress it up with all these quotes and all these kind of fancy many worlds ideas, is because we're grasping around in the dark. And I think there are people who are willing to say there must be a theory beyond quantum theory, right? So there must be something missing, which is what Einstein and Schrödinger both believed. There's something missing from it. And people said, no, it works really well. All the experiments, you get out the result that quantum theory tells you you're going to get. And that's only partially true, because quantum theory doesn't tell you anything apart from, like, if you calculate it and you do like 100,000 experiments, this is the result you'll get on average, right? That's what quantum theory tells you. But what it doesn't tell you is if you do that experiment once, you'll match up with the theory, because there's like a huge gulf between the theory and what it says about experiments. So it's kind of not really true what we say about quantum theory always matches with experiments, because it only matches with experiments on average, right? It doesn't do it individually. So Einstein and Schrödinger both knew this, and they both walked away from it because of this, because nobody was either facing up to it or able to resolve it. And they thought, let's just go and do something more interesting. And I don't think we've moved on a great deal since that point, really. And yeah, there are lots of physicists who will tell you and have told me, there must be a theory underneath it. We need to look for, something that causes these, wave function collapses, if you like. Although you won't get any two sort of agreeing on what a wave function actually is. Is it a real thing, or is it a description, or is the thing that we're holding in our hands when we have an atom? And when I'm giving this talk, I sort of about 10 minutes in, I tell them that really this is a talk about how a light bulb works. Because this is how the whole thing started, with Max Planck trying to work out how a light bulb works. And that's why he had to invent quantum theory, which he said was an act of desperation. And ever since then, we basically, we've invented like multiple parallel universes in order to be able to explain how a tungsten filament light bulb works. I mean, and we're now 120 years on, and we're still in this position where we're kind of making shit up in order to kind of give ourselves a sort of sense that, yeah, we're getting somewhere with this. And so, we need experimental results that undercut like quantum theory, because we know quantum theory must have something underneath it. There must be some other thing. We assume that the universe is random because, quantum theory has randomness, but quantum theory only seems to have randomness if you think that that's the absolute final theory of the universe. And this is what Einstein never accepted. He's like, there must be something missing. And I think, hopefully we'll find a way of doing experiments that show us the missing thing. But we haven't got there yet.
So I had heard this term superdeterminism before. I'm sort of friends with Sabina Hassenfelder.
Oh, yeah.
And I think she's into superdeterminism. She is.
Yeah.
I never really, I never read her descriptions of it as carefully as I should have, in part because I know that I think she uses it to disparage free will. And I'm a hardcore believer in free will, and so I'm actually not that interested in arguments that demolish free will, because I'm sure it exists. So I know that argument.
John, you should never declare your biases. What are you doing?
It's too late. I can't help but blabbing about my biases. But superdeterminism, the way you described it, was really fascinating to me. I wonder if you could just say a little bit about it. It strikes me as, is it kind of sort of the ultimate hidden variables?
Yeah, so it's related to the idea of hidden variables, which is, when there's something in your experiment that you don't know about, and that's the thing that's causing this result. That you see the result, you know why the result happened, and so Louis de Broglie in the 1920s, and then it was reinvented by
David Bohm.
Again in the 1950s, and the idea was like there's something missing that we can't see that would explain what all these things are. And we've never been able to find those things, and we should have been able to see those hidden variables from that pilot wave theory, as David Bohm called it. So superdeterminism kind of takes it a bit further than that. And I'm not sure who really originated the idea. There's a Dutch physicist called Gerard Hooft, who, he's a Nobel Prize winner, right? So he's no idiot. And his sort of view is to say, well, there's some kind of connections between all of the matter in the universe, effectively, so that when you do a quantum experiment, you think you're setting the experiment up with the inputs independent of the detector. So you set the detector, you set the inputs, and then the thing goes in and the detector detects something, and then you can say something about like what the universe is made of. And the view of superdeterminism is to sort of say, well, actually, what if you can't separate out this set of atoms in the detector from this set of atoms that you're putting into your experiment? And what if the settings for your detector actually change like whatever it is that's going on inside those atoms to give you a certain kind of output? And then, so you can set that up so that you might see something that you think is suspicious. It's like, there's these weird sort of links between stuff. And superdeterminism basically is saying, well, if there's links between all these atoms, then we can't do experiments in the same way that we think we can do experiments. And then instead of really engaging properly with that, this is what I think has happened. Instead of really engaging with that idea, and there's a lot of flaws and problems with the idea, and it's difficult to really access, and it doesn't necessarily give you anything that you can sort of do experiments on and sort of find out whether it's right or not. But instead of really engaging with that idea, I think what most people have done is say, oh, that's ridiculous. That's like a conspiracy theory. You're basically saying that no scientific experiments can ever say anything because everything is interlinked, and you've never got these statistically independent variables in your experiment. So you're basically saying if this is right, then the whole of science is a sham. And I think that's kind of the wrong way to react to the idea. I think the idea is interesting because, of course, in science, you assume that you can control your experiment, right? So you can say something about what that outcome of that experiment means. But what if you can't? That's effectively what I know Sabine Hossenfelder is sort of trying to set up as a discussion at the moment. And I think it's not a discussion that most scientists are wanting to have. I think that's what it comes down to. It's like she's saying, well, this is an interesting way of looking at things. And, she's not entirely alone. She's working, in fact, with a guy called Tim Palmer in the UK. He's at Oxford now. And he used to be a weather forecaster or research forecasting and climate modeling and all that kind of stuff. And he's very into and very knowledgeable about chaos theory and attractors, where things fall into certain patterns. And he independently started applying this and came to the idea that superdeterminism might be something. There might be things that pull behaviors in certain directions, like the strange attractors of chaos theory. And Sabine had been looking at it from the perspective of, I think she was trying to do some quantizing of gravity. And she ended up sort of looking at superdeterminism as a way of sort of, maybe you can get a kind of path into quantizing gravity, ending up with some alternative to string theory. And so she ended up with it. And I think Tim Palmer found her papers, or the other way around. And so they're collaborating now. And I spoke to her about it a while back because I was quite interested in her perspective. And she said they're finding it incredibly difficult to get papers published. And she said, basically it's the most unpopular thing she's ever worked on. And Sabine, as you know, has worked on some pretty unpopular things. So, but I think it's an interesting question. It's like, have we not been able to resolve these issues with quantum theory just because they're not really resolvable because of these links, and what we've sort of got down to is this level of, our experiments are finding connections between all of matter, say, the matter in our inputs, the matter in our detector, and what works on a macroscopic scale where we can control the independence of the variables does not work on the quantum scale. And that's an option. That's a possibility. I'm not saying it's likely.
Is this kind of the ultimate, are these connections between all the different parts of the universe, are they non-local? Is it sort of this extension of entanglement and non-locality to everything?
I'm not entirely sure of that, but as I understand it, I think what certainly Sabine is saying is that the non-locality is a kind of illusion that's created by these things, by these connections, but the universe is not non-local. I think that's right.
So let me ask you a sort of meta question. I started writing about science in the 80s. You started in the 90s. And back then, certainly through the mid 90s, there was this idea that it especially came from physics, but it came from other fields too. And Richard Dawkins, I think, contributed to this, Francis Crick, certainly Stephen Hawking. The idea was that science could basically solve the universe. It could get rid of the mystery. So we look at the world now and we go, what the hell? We know a lot of stuff, but there's so much we don't know. And our leading theories like quantum mechanics, as you've been saying, raise more questions than they answer. But there was this hope, we keep plugging away. And actually we're on the verge of a theory of everything. That term was bandied about quite a bit, and it meant different things to different people. But the way I looked at it is that we would achieve a kind of omniscience, and it would be not like a spiritual revelation, although that's what the rhetoric sounded like sometimes, but it would be this rational, empirical vision of the world. And the more I look back on that period, I totally bought it. That was one of the reasons why I wrote my first book, The End of Science. I was just so awestruck by that idea of omniscience that I decided to explore it. And I ended up writing a book saying, no, we know a lot, but there's certain things that we will never know. But I look back increasingly on that period in the 90s, Steven Weinberg, Dreams of a Final Theory, all that kind of stuff. John Barrow, who I mentioned, he also wrote books about theories of everything. I look back on it as pathological, like it's kind of mass delusion that really smart people succumb to, and it was also just this unbelievable arrogance among scientists to think that we're on the verge of understanding everything. And now I see that kind of all crumbling, falling apart. And I, so my writing has become increasingly skeptical. I'm more headed in the direction even of postmodernism, which I always rejected. I mean, I think science discovers things. We know a lot of stuff now.
Yeah.
That we never knew before. It's not all sort of constructed and invented. It's discovered. But when it comes to, we're clueless still about how matter generates mind and consciousness and all that. And it looks like we're going backwards, actually. So I guess I'm just bringing this up to see how you feel about this possibility of really someday understanding the world, maybe with the help of, this is tacked on to these claims that maybe it will be machines that discover the final theory if we mere humans can't do it.
Yeah. I mean, I have a lot of thoughts about everything you just said. All right, it's good to have ambition, right? So what you kind of classify as arrogance, I think you could reclassify as ambition. It's like we want to, this is what human beings do, right? This is what sets us apart in so many ways. is that we want to understand the world around us. We want to tame it. We want to ultimately, the governments pay scientists in order to tame it, to produce technology that boosts GDP. I mean, that's kind of what it comes down to. But then scientists, subvert that by just doing like this purely kind of investigative blue skies thinking about how the world around us works. And so it's a kind of trade-off. Like science is a trade-off between utility and, this kind of utopian desire to just make sense of the world around us, which is the same desire that manifests in I think in religion and philosophy and other things. So I don't think there's anything wrong with that. I think there's in fact, I think it's impossible for us not to do that. So once you have a theory, like, Newton developed a theory that, showed how the planets worked and, why the orbits were as they were. It's like, this stuff works, right? You've got maths and this shit like does get stuff done.
Right.
And so you're in this position where you're able to say, okay, so what can we now do with maths? What's the next thing we can do with maths? And, we move on a century or so and we invent the steam engine and we use maths to make it better. And everybody's happy, and then we take that same maths that we use for the steam engine and we start talking about the second law of thermodynamics and then trying to apply that to the whole universe. And all of a sudden we're in this position of like, wow, we can describe things in the universe maybe when we do this. So it's a natural progression. I don't think it's necessarily arrogance. I think it's just ambition, and it makes your eyes go shiny. It's like, wow, can we really do that? Can we pull this off? And then you have somebody coming along like Einstein who explains how gravity works in terms of curvature of the universe. And we see, we make astronomical observations that confirm this theoretical idea that he was able to express in like, 5-page paper or something, it's just like, well, I mean, that's general relativity, so it's longer, but all this stuff, it seems to respond to maths, right? So what you're going to do, you're not going to stop doing maths because it's been successful. So you carry on and you carry on. And then we get to the point where, you've got the standard model and you start doing accelerator experiments to kind of verify that indeed you can find these particles of the standard model. And it's incredibly successful. And you have mathematicians who are working on theories who say, well, actually, the maths tells us that we should look for this kind of thing. And we look for it and we find it. And it's like, wow, this is incredible. So at what point are you going to stop doing this?
Yeah.
You're never going to stop doing this, right? Because this is cool. This stuff is great. The governments don't know that it's of no use whatsoever, and they'll keep giving us money, so that's fine. And we'll have some spin-offs from this, that, and the other. You get a spin-off like nuclear fission, which governments are very, very happy to discover. And so it's a kind of mutually beneficial situation. But ultimately, the physicists are still saying, "I want to know how the universe works." And by the way, we're finding particles from the standard model, and the standard model all works, and it's great, except that you then do a thing where you say, "What is a particle?" By the way, and we don't know, and we may never know the answer to that question, which I find hilarious. There was a great article by Natalie Walchover in Quanta recently. I don't know if you saw it. And it was basically, asking all these physicists, what is a particle? And you get this like whole spectrum of answers. Nobody knows what a particle is. Obviously, when it comes to quantum stuff, is it a wave or is it a particle? Well, it depends how you want to view the experiment. So nobody knows what this stuff actually is, but we can find mathematical descriptions that work. And so, of course, the next level is, well, maybe we can describe how the whole universe works. And you remember that slogan, the universe on a T-shirt?
Yeah.
It was like, we're going to have the equation of the whole universe that describes everything. And it's going to fit on a T-shirt. And this was a kind of, the Weinbergian dreams of a final theory kind of approach. I don't know if I would agree with you that it's crumbled away. I mean, it's hit some serious hurdles. There's difficult stuff to overcome. And there's no reason to think we'll ever get to the end of it. I don't think there's any reason to think certainly we should have solved it by now, and why haven't we?
Yeah.
I remember I a couple of years ago, I talked to a string theorist in London who was great. And he just said, I spent my whole career working on string theory. It clearly isn't there yet. And there's no reason to believe that it will be there in my lifetime. And he said, and to be honest, there's no reason to believe that it will be there in 100 years' time either. This might be one of those really, really long-term projects that involves maths that hasn't been invented yet. There's kind of, but as human beings, we can't stop ourselves sort of trying to do this thing. And we've got relativity and we've got quantum physics, and they don't work together. Like, you can't just like, glue them together and make a final theory that sort of describes everything in the universe. So we do have to kind of go back to basics and work out why this theory works and why that theory works, and how you might sort of do have one theory that has, takes components from both. And so yes, there is this kind of, it seems like arrogance but I think it seems like arrogance because it treads on the toes of sort of spirituality. But I don't think that it's necessarily a bad thing that it treads on the toes of spirituality.
Yeah, that was really well said. I guess I understand how ambition is maybe a more fair term than arrogance. It's the idea that there is an ultimate theory that we can find that I'm beginning to see as increasingly foolish and also dangerous.
It's naive. I would give you naive.
Well, by dangerous, I mean that I can see, there have been many times in our human history when lots of people thought that they had the final answer to human existence. Both in terms of religion and even secular ideas like Marxism, or you've got these kind of gigantic ideologies that are based on science and reason supposedly, and there are all these true believers. And to the extent that we think we have the ultimate answer, it prevents us from looking for other answers and from taking other answers seriously. So I think it's actually healthier, and this is sort of a philosophical position I've been pushing lately. It's healthier to get rid of the whole idea of a final theory or an ultimate theory, ultimate truth, and accept that, we find these theories like quantum mechanics and relativity and even natural selection, the genetic code, that are extraordinarily effective in a certain domain. But that doesn't mean that there are all these other, that there aren't other ways of understanding reality that might be even more effective. I think that's a healthier attitude for scientists, and it's probably the attitude of most scientists, not the ones who write the best-selling books. Right?
But you know what? The interesting thing is people write the best-selling books because people want to read the best-selling books, right? You don't, when you write it, it's not a bestseller, but somehow you hit something that people actually want to know about, and they want to, the reason why all those people bought a brief history of time is because people want answers. Okay. Yeah. And so they look to a certain type of physicist for answers.
Yeah.
And we had Stephen Hawking, we had Weinberg. At the moment we've got Carlo Rovelli, I think, as emerging as almost like the successor to Hawking in some ways. And it's interesting because he has a new book out I haven't read yet. I read The Order of Time, which is a wonderful book, but doesn't give you the answers. He admits as much towards the end of the book. He says, I'm playing around here, really. I don't know how much what I've said about time really corresponds to how time really is. So we want to understand what time is, but actually none of the experts know what time is. And yet we have this human hunger to kind of, to at least grapple with the answers. And so when you say that, you think other means of pursuing answers might be more effective, I'm guessing, you're talking about a kind of spirituality kind of approach or philosophical kinds of approach. But my point is, how do you define effective, right? It's effective if we enjoy the search for the answer without having to get to the answer.
Right.
Because we're not going to get to the answer. I don't know if there's going to be a final theory. Why should there be a final theory? So that's an arrogant thing to say, there will be a final theory, because we don't know ultimately how the universe works. Let's face it, we don't actually know what particles are and space and time are and anything else. So how can we make a definitive statement about there is a final theory? And I have quite strong opinions about mathematics as being incredibly useful, but I see it much more as invention than discovery.
I just was, my next column for Scientific American is going to be making that very point. The headline, my working headline is the Schrodinger equation true? And it's like, just because it works doesn't mean it's true. And nobody can say what the Schrodinger equation actually means, how it actually matches up against the physical world.
But true isn't the right measure, is it?
Yeah. We've already talked for an hour, and I wanted to ask you about your next book. Also, I wanted to make a plug for, so you've got a book that came out, I think last year. I've got a book that's coming out this month.
Yeah, which I've read.
Yeah, I
really enjoyed it.
And this is the correspondence I see between this and your book is that I'm trying to, I've always been struck by how my own thoughts are. I like to think that I'm capable of rationality, but they're swirling around with all these other emotional thoughts that are involved, that have to do with my relationship with my girlfriend and my children and my students and all this kind of stuff. And I try to be reasonable, but often I fail.
What made you? Could I interview you now? Because I'm having read the book, right, and really enjoyed reading it, and knowing how true it was to you, as I know you and I understand who you are, and then having read so much of your stuff, and we've talked, late into the night on occasions. What made you want to go down the path of just writing this down and kind of? I mean, it's a kind of self-exposing kind of book, isn't it? Yeah.
Actually, the proximate cause was that I reread. I got my first Kindle. This is quite a while ago now. It must have been 8 years ago or so. And one of the first books I read was Ulysses by James Joyce. And I just, wow, this is amazing. And it made me, reading this stream of consciousness work, made me extremely conscious of all the stuff constantly swirling through my own head. And as I said, I've always been struck by how contradictory my own thoughts are. And so I wanted to sort of, for my own purposes, I wanted to lay it out. I don't know if anybody, I'm glad that you like it. I don't know how many people are going to want to read this book because in some ways it's very self-indulgent, but it was a wonderful exercise to try to be hyper aware of my own thoughts as I went through the course of a day. And that's the book. The book is basically about a typical day in my life. And it was so it was a lot of fun to write and sort of take notes on. Oh my God, I just thought that's interesting. I'm going to write that down, and the odd things that pop into my head as I'm going through my daily routine.
Yeah, I mean, for a lot of people, I would say those thoughts that pop into your head are definitely not ones you want to share with anybody. But you're kind of fearless with that. And it's like, fine, I'm going to put that in. That's who I am. That's how I think. That's how my brain sort of alerts me to stuff.
Well, I changed the name of the narrator and his girlfriend. That was actually at the insistence of my girlfriend, who is horrified that this book has been published. But anyway, I'm still kind of astonished that it has seen the light of day, that I found a publisher to put it out there.
Well, I mean, so it's interesting because you say there are parallels between this and the Quantum Astrologer, and I wrote that book in my spare time because I didn't think it would ever find a publisher, but I had to write it because it was just going on in my head, and this stuff was going on in my head. And these conversations with Cardano were going on in my head, especially the more I read about him. So the more, I started to pay attention, if you like, to what my brain was interested in. The more I had to just get this stuff down on paper. And it took 8 years of my spare time to write The Quantum Astrologer. I wrote 2 other books in the time in between, always thinking I need to just put this aside and forget about it. This is the kind of thing to bring out when you're 80 and just, and I never managed to do it. And eventually I finished it. And I said to my agent, I'm really sorry, but I've got this manuscript I'd like you to read. And he loved it. And it was published, and it's great. But there is that side of, maybe it's sort of, people who write for a living where they become obsessed by this thing that's going on in their heads and in their lives. And you have to write it. Otherwise it just will never go away.
Yeah. And for me, it's cathartic. It's my therapy. It's my spiritual path.
Yeah.
For ill or good. And the downside is that everything that happens to me, my entire life is just material for my writing. But I used to worry about that, but now I've just accepted it.
Yeah.
But anyway, let me ask you. You're working on another book.
So
right?
I'm working on another book, and the interesting thing about this is that I realized about 2 months into the project that if I was obsessed by Jerome Cardano, right, and that's where the quantum astrologer came from, and he was this incredibly obsessive and brilliant mathematician. And one of his great projects, which got him into all kinds of trouble, was a book that he called The Great Art, which is where he wanted to lay out all of mathematics and how it worked for the layperson. So like the person in the street would understand what mathematics was. I found myself sort of writing a book proposal for a book that I called The Art of More, which is about mathematics. And about 2 months into the project, I suddenly realized that if Cardano could have controlled me from the grave, this is the book he would make me write. So this book is about the maths you learned at school and how actually, you didn't know it and nobody taught you this at the time, but actually this is the basis of all human civilization. And you don't ever get taught this. You get taught how to pass the exam, right? You get taught how to do this and then move on to the next thing. And you do 100 examples of that. So you drill through it and you can now do calculus. So, you can differentiate or integrate or whatever. And so I wanted to do a book that kind of pulled all that stuff apart and said, but, this stuff must exist for a reason, right? I mean, we're not differentiating just to pass an exam, surely. And so I went through all the subjects. So that there's a chapter on arithmetic, and then geometry, and then calculus and algebra and logarithms, and then we get onto statistics and then information theory. And in each of those chapters, I try and pull it apart and like, this is what it is. This is where it came from. This is what it was used for. And it was, you probably won't ever use differentiation in your life, apart from as a leisure pursuit if you want to learn how to do quantum mechanics, right? But this is this is why people invented it, and this is what it helped us achieve. And it turns out when you investigate all of this stuff, that the kind of central thesis of the book, now that I finished it, I realized, is that you cannot have human civilization as we know it without mathematics. It just doesn't work. So every civilization that you ever come across has had mathematics, even if they haven't had writing. So the Incas didn't write stuff down, but they had mathematics that was encoded in knotted strings, and they took census data and they kept records of things. The Babylonians invented the quadratic equation solution as basically a tax calculating tool, So the minute you have states and rulers and government and, civil servants, then you have to have mathematics for them to do all their stuff. So the Egyptians were calculating, when the Nile was going to flood, and then they would reallocate all the fields to people, on mathematical basis using geometry and stuff. And if you want to navigate the world and go and pillage other nations, then you basically need to know geometry. It's basically the geometry of right angle triangles, sines, cosines, tangents, gets you, sailing around the world safely, and you're able to go and conquer other worlds. It's sort of, there was a 16th century French navigator who said, he sort of shrugged his shoulders in a very Gallic way, I imagine. He said, it's just right angle triangles. That's all you've got to know. And so this book, The Art of More, and the reason it's called The Art of More is partly because it rhymes with the art of war. But when we are babies, when we're born, we can distinguish three objects. So we can count up to three. And everything after that is just more to us until we learn language for counting, and then we learn how to count properly, And so the idea is that maths is the art of more. It's like the art of going beyond three, and then everything that you can do with all those numbers.
Damn, it sounds great.
It's been such a blast to write. I've never enjoyed anything more.
I think, I could use a book like that. And it's directly related to this column that I'm working on. As we were just discussing, the question is, I just reread Eugene Wigner's essay, The Unreasonable effectiveness of mathematics. And what surprises me is that I thought he was another math is discovered, and it's this mysterious thing, but that's the language of the universe. And that's not what he's saying at all, really. He's questioning that dogma. And he's saying the math works really well in a particular context. It'll do the job, but there's no reason to think that there aren't these other theories that could also work really well. Math, I think he's definitely going with the math as an invention. It's a very effective tool. No tools are universally effective. Yeah. And that's kind of what I'm running with now in this, because of all the math that I'm learning because of quantum mechanics.
Yeah. Yeah. It's interesting. So one of my things early on, I'm not sure how wedded I am to it now, but certainly early on in my research, not only did I sort of decide that math was definitely invented, I also don't think we categorize it properly. I don't think we've classified it properly. So when we learn stuff at school, we have the humanities and we have sciences and we have math, and we tend to associate the math much more with the sciences. It's like a tool for the sciences. But actually, studying like history of civilizations and looking at the math that they do in these things, it seems to me it's much more, it's also a tool for the humanities. If you want to set up law, taxation, governance, mathematics is behind it all. And there was maths being used for law, economics. You can't have trade, for instance, without math, right? And so math was being used as tools for those things far, long before it was ever used in science. I mean, science is such a recent invention. And so I kind of think we classify math as something that only science students need to know. But I kind of feel like it should be lumped with the humanities. It's like, if you want to really understand history, civilization, law, economics, you need to understand what maths enables in those things in order for them to function. So I'm kind of looking to reclassify maths, really.
What's brilliant about that idea is, apart from whether or not it's true, and that sounds like a very plausible argument to me, that thesis will get you invited by all the humanities departments at major universities, that are trying to.
That'd be great. I'm open to invitations.
Yeah, I mean that's a really provocative idea. That sounds.
It's certainly been owned, hasn't it? Don't you think it's been totally owned, and like safeguarded by the sciences? It's like maths is our thing.
Yeah, and it's put up, especially with physics. I think it's put up as a kind of fence, keeping out people like me, keeping out the non-professionals, and so your thesis is very inclusive and saying that mathematics is integral to all of civilization.
Yeah. Yeah.
That's great, man.
Yeah.
All right. We're over our usual allotted time, so
sorry.
We'll have to wrap it up there. I can't wait. When do you think this thing might actually?
So it's I think it's due for publication in September next year, so 2021 September.
Oh, fantastic! That's soon.
Yeah. I mean, it's pretty much done. I finished the second draft. Now it has to go through all those processes of editing and kind of finessing. But I'm really pleased with it. I mean, it's one of those books that every day, at the end of the day, I would bore my family rigid about like the thing that I'd learned today. It's one of those things you can't help but share, like this little fact that you've just come across.
Yeah, I've bored my girlfriend by trying to tell her what normalization is and stuff like that. She's like, oh, please. Okay, so make sure that I'm on the list of people for galleys. I definitely would like to read that as soon as it's available, because it'll help me with my quantum project.
Yeah, I hope so.
Michael, thank you so much.
Thank you for having me, John. It's been great.
I've really enjoyed it too. Good luck dealing with all the shit happening in the world. I'm glad you're staying busy through all.
Yeah, me too.